Now let's now look at another measure of association between two variables, which is the correlation coefficient. So correlation coefficient. And from now on, I'm gonna write CORR COEFF. That should be understood as correlation coefficient. Okay. So the correlation coefficient measures the linear relationship between two variables. Okay. So how do we compute the correlation coefficient? Suppose we have population data, then we can compute the population correlation coefficient, which is denoted by the Greek letter rho xy. So this is the population correlation coefficient between two variables x and y. Rho xy is going to be equal to sigma xy divided by sigma x times sigma y. And just to remind ourselves, sigma xy is the covariance between x and y in the population. Sigma x is the population standard deviation of x. Oops, and over here we should have sigma y. And sigma y is the population standard deviation of y. Again, remember that we don't usually have access to the population, so we can calculate the sample correlation coefficient given sample data. Now the sample correlation coefficient, which is denoted by Rxy, is equal to Sxy divided by Sx times Sy, where Sxy is the sample covariance between x and y. Sx is the sample standard deviation of x, and Sy is the sample standard deviation of y. Okay. So if you want to calculate the correlation coefficient, you just need to take the covariance and divide it by the product of the sample of the standard deviations. Now, what should we know about the correlation coefficient? The correlation coefficient always lies between -1 and 1. So I'm gonna go ahead and use the talk about the sample here, but everything applies to the population as well. Okay. So if the correlation coefficient is 1. So if Rxy is equal to 1, then there is a perfect positive linear relationship. So positive and perfect linear relationship. Yeah. Now when it is 0, then there's no linear relationship. So if Rxy is 0, no linear relationship. If it is -1, then there is a negative and perfect linear relationship. Right, so if Rxy is equal to -1, then the relationship is negative and linear. So perfect linear relationship. Okay. And the idea is the linear relationship becomes weaker as the correlation coefficient gets closer to 0. So as Rxy goes to 0, the linear relationship becomes weaker. Okay. So now what I have here is 1,000 words. Right? It's a picture, and a picture is worth 1,000 words. So anyway, that's a joke. So notice that when the correlation coefficient is -0.9, right, the linear relationship is negative, okay, and looks very strong, right? As we approach 0, the linear relationship becomes weaker and weaker, right? When the correlation coefficient is 0.9, then there's a strong positive linear relationship, and when the correlation coefficient is 1, then all the points form a straight line, right? They all lie on a straight line in the xy coordinate. Okay. So I hope that this picture is gonna show you the interpretation of the correlation coefficient. So in this video, we define the correlation coefficient, we learn how to calculate it, and we talked about what the correlation coefficient tells us.